A nuclear fusion-powered rocket engine, SpaceX begins testing a new Super Heavy booster, and NASA looks ahead to sending humans to Mars. The race towards nuclear propulsion in space has a new contender, Pulsar Fusion, and this UK-based company believes they are developing a rocket that will not only make travel to Mars much quicker and safer, but will also open up the possibility of getting humans all the way to Saturn and beyond. As you might have guessed from the name, Pulsar Fusion is one of a small handful of companies attempting to figure out how to effectively use nuclear fusion to drive our ships deeper into space. The company also designs a couple of other propulsion types, like their hybrid HDPE engine, which burns recycled plastic. The company's main goal is to create efficient propulsion as cleanly as possible, which is why their most important product is a nuclear engine. As their site says, the direct fusion drive is a compact nuclear fusion engine which could provide both thrust and electrical power for spaceships. Fusion engines operate using a reactor which smashes atoms together rather than splitting them apart like a more conventional fission reaction. The heat of this process is used to create electricity and, in Pulsar's case, will be used to ionize the gas that's actually used as propellant. That gas is heated in a chamber constrained by magnetic coils, sort of like how a microwave operates. Then this plasma is shot out of the engine for thrust. It's a similar method to existing ion thrusters used for deep space probes, but a fusion-powered reaction would accelerate the propellant gas up to 1,000 times faster. In this way, Pulsar's DFD isn't really a fusion engine, it's a magnetoplasma engine, but that's sort of splitting hairs since both make use of a fusion drive anyway. The process heats the plasma to several 100 million degrees, hotter than our sun, but that's not even the most challenging part of the system because hot magnetic plasma is very difficult to control apparently. Pulsar's chief financial officer, Dr. James Lambert, explains the behavior of plasma to be like a weather system. It's very difficult to precisely anticipate how it will flow out of the reaction chamber, which might kill the whole process before propulsion can start. But the efficiency of this type of engine is enticing. While not as efficient as a pure fusion engine system would be, the DFD should be extremely easy on fuel. ISP, or specific impulse, is a measure of the change in momentum per unit of fuel. Comparing Pulsar's DFD to another vacuum engine like the SpaceX Raptor's vacuum variant, we see that the Raptor has an ISP of about 380 seconds. The DFD has a proposed ISP of 105 seconds. Much more efficient, albeit slower. The benefit of this sort of fusion engine is that it uses so little fuel, it can afford to burn constantly, increasing the acceleration time. Chemical rockets sprint where nuclear and electrical engines run a marathon. According to their preliminary numbers, Pulsar's new engine could reduce travel times to Mars by as much as half, allow for a 2-year travel time to Saturn, and get a small 1,000 kilogram craft from Earth to Pluto in just 4 years. We are talking about an exponential increase in human explorable space. There's just one small problem, of course. A fusion reaction like this doesn't exist yet. In 2022, the Lawrence Livermore National Laboratory in Livermore, California, achieved the first fusion ignition, which broke even, meaning that the reaction produced more energy than was put into it by the laser they used to start the process. Some of you might recognize the reactor from the J.J. Abrams Star Trek movies because it was used to film the scenes with the Enterprise's warp core. It is a humongous piece of machinery that would never fit on a rocket. The fusion experiments at Lawrence Livermore have kickstarted a surge of research and development in fusion technology. Fusion is the future of clean energy. That's an easy reason to back the research, but the chance for such a powerful new method of propulsion couldn't be ignored either. Pulsar's resident scientists have used the research from Lawrence Livermore to design a relatively compact system that could fit on a rocket, even with the addition of magnets to control the plasma needed for propulsion. Partnering with Princeton Satellite Systems, the company plans on using the Princeton Plasma Physics Laboratory in New Jersey to finish their design. Princeton's labs have access to supercomputers and a reactor to test on, so the The plan is to run plasma tests in the reactor for data, then feed the numbers into Princeton supercomputers, running simulations in order to puzzle out the best way to control the flow of plasma in a real rocket. The team believes that they can commit to a full rocket test in 2027, having a conventional booster lift the fusion test vehicle into orbit, then lighting the engines. Fusion is still nuclear after all and creates a fair bit of radiation. And that's not an unachievable goal. Scientists had figured out the principles behind fusion almost 100 years ago before they nailed it in a lab in California. It's not so far-fetched to think that we now have the technology to stick that on a rocket and use it to speed up travel times. There really won't be any way of telling if this system can work until we get into space and turn it on, but the numbers certainly work out. If the team at Propulsion Fusion can focus the magnetic firestorm in their engines, this could very well be the technology that makes local space travel easy. SpaceX has begun testing a brand new launch system for their Starship rocket in Boca Chica, Texas. The team managed to fully install the massive water lines from the tank farm to the new deluge plate under the orbital launch mount within just a few days. There still needs to be more concrete poured to cover all this exposed infrastructure, but SpaceX wasted no time purging the lines of all the dust and debris that had built up during the construction process. After that, some tests of the OLM systems like the quick disconnect hood and the ports that feed the outer ring of Raptor engines on Super Heavy the gases needed to start them up. And then on the 17th, our first view of the deluge system in use. The system was only hooked up to 2 of the 3 tanks it was designed for, but it still managed to throw out an incredible amount of water, and in almost exactly the way theorized by Ryan Hansen in his visualizations. The team will almost certainly test the system a few more times before even a static fire test is attempted. As they add in the last tank and pour the last bits of concrete over the area, they'll need to figure out if their drainage systems work under a full-strength load of water after all. But the truly wild sight came on Friday the 21st as SpaceX maneuvered Booster 9 onto the OLM using the launch tower's arms. These systems hadn't been tested with the full weight of a booster, even an empty one, since the destruction caused by the Starship test launch on April 20th. And while it was a little risky to place the booster on the OLM while the surrounding concrete was still hardening, everything worked out fine. Obviously, the OLM has a lot of support built in, but the danger is that concrete can take weeks and even months to fully cure after it visibly hardens, and putting such a heavy weight on a fresh pad while it's still going through that process could cause damage in the structure. That said, the SpaceX team hasn't poured the entire pad yet, and with how quickly fondant cures, the engineers on site definitely know their tolerances better than we do. Back on the booster though, we did get to see that although Booster 9 is the most likely candidate for the next flight, it doesn't yet have the new vent at the top for hot staging. That will definitely have to be added before a test, as the engineers already raised the height for the Starship quick disconnect just last week. But seeing all these systems working was great. The lift arms, the OLM systems, and the new deluge plate are all integral to moving forward with testing. Some folks seem to think that a static fire could be right around the corner, but there's a lot of work left to do before that can happen. Concrete drying aside, the team still need to modify Booster 9, give it pressure and fuel tests, complete the deluge system's tank area, test it again, and wait for the FCC investigation to complete. But SpaceX has a habit of defying expectations, so while cooler heads might say that a static fire couldn't possibly happen so soon, we should be ready for anything. New comments from NASA Administrator Jim Free indicate that the administration is beginning to look over their mission architecture for Phase 2 of their Moon to Mars program. They are starting to plan for sending humans to Mars. Jim is the Associate Administrator for Exploration Systems Development at NASA, and his comments at a July 19th symposium were specifically about the agency's architecture concept review. Basically, before NASA decides mission schedules and the partners who will help run them, they first need to look over proposals for the various objectives of the campaign that they want to run. Phase 2 of the Moon to Mars campaign involves the crewed missions to Mars, and so this review will be even more exciting than the one for Phase 1, which brought us the many new landers, rockets, satellites, rovers, and HAB designs we've been geeking out over since the Artemis missions were announced. So it's pretty safe to assume that by the time this review starts in November, we are going to have more than a few seriously cool new systems and vehicles to discuss. But the process of weeding all those applications down to the usable few is just as interesting, because NASA has to know what they are aiming for before making their choices, which means reviewing mission objectives and attaching them to specific missions, and then telling their partners what to design for, and that's already happened. During that symposium on July 19th we mentioned earlier, Jim Free said that NASA has already attached major objectives to the first 5 missions, and they've already been collecting feedback from partners on the first draft of their mission documents. This reportedly took place just last month in June with meetings and workshops. Jim says that the input from partner organizations was phenomenal, but of course, mission planning and designing with partners is the fun part. The tricky and often tedious part is planning for campaigns that will extend through more than one political administration. Funding tends to get cut under one government and is not often replaced afterwards by new administrations. So Jim says that the biggest job during these reviews is to plan for a potentially lower budget and then make sure they can deliver anyway. But the current leadership at NASA are old hands at navigating this sort of bureaucracy, and they've already been making use of their commercial partners to ensure success further into the Moon to Mars campaign. So, with the future more or less secured, we can safely look forward to all the new tech that will see us finally landing a human on the red planet. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.